statements you need to convert into roster method. The counting numbers which are multiples of 6 and less than 50. What will be the set? Let's say the set is A equals to multiple of 6 means and less than 50. 6, 12, 18, 24, 30, 36, 42 and 48. So that's how you can represent in the form of roster. And if you are asked to represent in the form of set builder or rule method, how you can do that? A equals to x is the variable colon x equals to 6 in and where comma in is natural numbers x less than 50. So these are the conditions. So x will be less than 50 and n is the definition natural numbers. X equals to 6 into 1, 6 into 2, 6 into 3, and that's how it will continue till 6 into 8, 48. Got it? So that is how you can express in the form of roster and in the form of set builder or rule method. Let's say another problem. X colon, it is given in set builder form already. X colon, x is a set of n. I will explain that in a next video. The generic expression, when it is n means natural number, capital N means natural number, capital R means real numbers, right? So x is a member of natural numbers, right? And x is a prime factor of 84. Prime factor. What are the factors of 84 you have? Out of that, which one is the prime factor? Right. So there are two conditions. X is a member of natural number and x is a prime factor of 84. What is the prime factor of 84? Prime factors of 84 is 2, 3, 7, 7 12 is 84, 3 into 28, 84, 2 into 42, 84. So that is how you need to find out the prime factors. How can I write down in form in roster form? It is 2, 3, 7. These are the prime numbers. X is the prime numbers, right? X is a member of natural numbers. X is a prime factor of 84. That means 2, 3, 7, all these are natural numbers as well as prime factor of 84. So this is in roster form. So set builder form or rule method, that is in a generic expression in logical form, in the form of variable. Set of odd integers, number 4, set of odd integers lying between -4 and 8. Odd integers. It could be positive integer, it could be negative integer. So after -4, in between -4 and 8, what are the odd integers? -3 and then 3, 5, 7, -3, 3, 5, 7. These are the odd integers, right? So it will be -3, 3, 5, 7, right, up to 8, in between -4 and 8. So that is how we can explain in the form of, express in the form of roster form, roster method, right? So this is number 4. Number 5, the set of all natural numbers x for which x plus 6 is less than 10. Okay, how can we express with respect to roster form? Set of all natural numbers x for which x plus 6 is less than 10. If x plus 6 is less than 10, that means x less than 10 minus 6, that means x less than 4. So if it is x less than 4 and x is natural number, that means all the set of all integers, all natural numbers, that means 1, 2, 3. 1, 2, 3, x is less than 4, 1, 2, 3. That is how we can express in the form of roster form. And sometimes it will be given in the roster form. You need to convert into set builder or rule method. A set of all letters in the word trigonometry, right? So I will take all the letters once only within the set. So what will be the set? So how it will be there within the set? Trigonometry. How many letters are there? We can see here you have total how many letters? 1 2 3 4 5 6 7 8 9 10 11 12. There are 12 letters. But in the set, how many letters will be there? Let's see. It is T, then it is R, then it is I, then it is G, then O, then it is N, O is repeated, will not take, will take M, then it is E, T will not count, already we have, R already we have taken, Y will take. So how many letters are there in this set? 1 2 3 4 5 6 7 8 9. Even though the spelling trigonometry has 12 letters, but in the set it will be 9 letters. So this is how the roster form works. If you like this video, please click on the like button, and if you would like to have the notification as soon as I upload it in YouTube or Facebook, please subscribe my YouTube channel Debs Learning Hub and also follow my Facebook page Debs Learning Hub. Thank you very much.